In the figure below, the two circles intersect at points F and H. Points A and B are the endpoints of a diameter of the larger circle. Prove that the circles are orthogonal. Let's analyze this problem a little bit. In the previous video, we have learned that two circles are said to be orthogonal to each other if the radii drawn to a point of intersection are perpendicular. That is, what we need to show is that the measure of the angle DFH is 90 degrees. To show this fact, we will consider the quadrilateral DHCF. Also in the previous video, we have shown that the angle DHC is congruent to the angle DFC. Note that the angle sum of the interior angles of a quadrilateral on the Euclidean plane is 360 degrees. Hence, if we're able to show that the measure of the angle FDH and the measure of the angle FCH sum up to 180 degrees, then the difference between them would be 180s. And we must have the sum of the measure of the angle DFC and the angle DHC is 180 degrees. Since those two angles are congruent to each other, we can conclude that both of them are of measure 90 degrees. Therefore, to prove this problem, what we have to show is just the fact that the sum of the measure of FDH and the measure of FCH is equals to 180 degrees. Okay, now let's think about how to proceed. In this argument, we would make use of a few properties of those various types of angles related to circles on the Euclidean plane. For instance, the first observation is the angle FCH is a central angle of the larger circle intercepting the arc, which is denoted by FPH. Therefore, we conclude that the measure of FCH is equal to the measure of the arc FPH as central angle. Meanwhile, we also note that the angle FDH is a central angle of the smaller circle intercepting the same arc as the inscribed angle FEH. Therefore, the measure of the angle FDH is the double of the measure of the angle FEH. But what is the measure of the angle FEH? Well, we know that this angle is in fact a 2 secant angle for this larger circle. Therefore, the measure of this angle is equal to 1/2 the measure of the arc AQB minus the arc, the measure of the arc FPH, which is the same as the measure of the arc AQB minus the measure of the arc FPH by the 2 secant angle theorem. But we note that the chord AB is a diameter of the larger circle. That is, the arc AQB is in fact a semicircle. So the measure of this arc is precisely 180 degrees. Now, if we put everything together, we will have the following conclusion. The sum of the measure of the angle FCH with the measure of the angle FDH is equal to the measure of the arc FPH plus the difference of the measure of these two arcs. But these two measures would cancel each other. So what we are left with is just the measure of the arc AQB, which was shown to be 180 degrees. And this is precisely what we like to show, right? Because we want to show that the sum of the measure of this FDH and the measure of the angle FCH is equals to 180 degrees. Once we get this conclusion, we could go ahead to conclude that the measure of the angle DFC is equal to a half of 360 minus 180, which is precisely 90 degrees. Hence, we conclude that these two circles are orthogonal to each other. Thank you for watching. See you next time.